Alright, hello guys. Our job today is to derive the compound angle formula for tan. So our job is to prove that the tan of A plus B is equal to tan of A plus tan of B over 1 minus tan A tan B. Alright, now in order for me to do this, I must recall the identities that I would have learned earlier. Bear in mind that we all know that the tangent of an angle, so if I have tan theta, it is equal to sine theta over the cosine of theta. What does that mean? Alright, that would mean that the tan of A plus B would be equal to the sine of A plus B over the cosine of A plus B. Now, we know the compound angle formula for sine, and we know the compound angle formula for cos. So let us change out sine A plus B and cos A plus B into their respective compound angle formula. So that would give me sine of A cos of B plus the sine of B cosine of A all over cosine A cosine B minus the sine of A times the sine of B. Now, where do I go from there? This is an expression, so there are several things I can do. I can multiply this expression by 1. It's the same thing as dividing all the terms in this expression by something. So once you have a fraction, you can divide all the terms by something as long as you divide the numerator and the denominator by it. What do I mean by that? If I have, let's say, 25 over 50, what it means is that I can divide the 25 by 25. So I can say 25 over 25 all over, and notice which fraction bar is longer, 50 over 25. So as long as I divide the numerator and the denominator by the same thing, then it is legal for an expression, because this will actually boil down to 25 into 25 is 1 and 25 into 50 is 2. So you see that does make sense. How am I going to use that now to do this? We know that in order to convert an expression sine to tan, we have to divide by cos. What does that mean for me? Let me just rub this out here. If I want to turn this entire expression into tan, it means I'm going to have to divide all the terms by the cosine. And since I don't only have cosine A, I have cosine B as well, I would have to divide every single term by cosine A and by cosine B. And we showed you a while ago that it was legal as long as you divide all the terms in the fraction by the same thing. Note, if it is not a fraction, then this approach cannot be taken. So this is exactly what I'm going to do. I am going to divide all the terms by cosine A, cosine B. So it becomes sine A cos B over cos A cos B plus sine of B cos of A over cosine A cosine B. Now my main fraction bar would be this long bar here, and I'm going to have cos A cos B over cos A cos B minus sine A sine B over cos A cos B. My primary task now is to see what can be reduced. Now, if I look at the very first expression, notice that we have a cos B here and we have a cos B there. So that is gone. In the second expression, we have a cos A there and we have a cos A there. So that is gone. Down here, we can say cos A, and cos B takes out cos B. So that is good. Over here, technically speaking, nothing can be cancelled out. So it means now I'm going to have to go back now and